Hello, my name is Juno Zderic. In this video I will provide an alternate way of viewing voltage, show you a physical comparison, a few uses of voltage, show how it can control voltage globally, and provide a brief history. So, we can visualize the circuit as a transport railway network, where the voltage represents a train ticket for the passengers, in this case a current, to each station, which are the elements in the circuit. No one can board the train without a ticket, legally that is, and the more tickets we have, the more people can board. At each station, we can buy tickets, or increase the voltage in real terms, or use them, or decrease the voltage. There are a couple of faults in this illusion, the first being that there is actually no current loss across any element, only voltage. The second is that when a path is split, the voltage remains the same across each path, like the train was duplicating itself for each track. In reality, however, the voltage is essentially a force which drives the current. Hypothetically speaking, if the current was too high for the voltage, it couldn't provide enough energy to allow the current to flow. This means that voltage and current are proportional, such as defined by Ohm's law, V equals IR, where V equals voltage measured in volts, I is the current measured in amperes, and R is the resistance measured in ohms. Voltage is a component for many equations involved in circuit analysis and physics. With it, we can solve for such things as current, resistance, power, work, and many more. These rules allow for a fundamental understanding of circuits and electricity. In an engineering scope, it is essential for circuit analysis, electronics in general, electromagnetism, junctions, and much more. To allow for domestic use, each electricity-consuming country has their own unique voltage constant. For Australia, this is 240 volts, chosen because it simplifies calculations relevant to it. We can control these constants with transformers. Transformers only work for alternating currents, as by Lenz's law and the laws of induction. This is a little off topic, so we won't venture into it too much, but essentially a step-down transformer has less coils in the secondary winding and a step-up has more. The person responsible for discovering voltage was Count Alessandro Volta, who also invented the first battery. Well, to be a little more in depth, in the 1780s, Volta's colleague Luigi Galvani first noticed voltage when cutting off a frog's legs when the legs twitched. He thought, however, that this was showcasing his theory of animal life force at the time. Volta reproduced the experiments later on, and explained that this was voltage instead. Thank you for watching my video. I hope this has helped you understand voltage a little more.